So, what exactly is a logarithm? Let's start with this 16 is 2 to the power 4. This is the power, the index or the exponent, and this is the base. If we take the logarithm, which we usually write as log, to base 2 of this number 16, then the logarithm is 4. This power, index or exponent becomes the logarithm. So we take logs to a base. And it's the base that gets raised to a particular power in indices, and that power becomes the logarithm. So these two are equivalent statements. If we write one, we automatically imply the other. So if I say that 64 is 8 to the power 2, that is exactly the same as saying that the log of 64 to base 8 is 2. These two statements are exactly the same. So if I write a statement down this side, it's exactly the same statement written down here. They both mean the same thing. So that if this side I say the log to base 3 of 27 is 3, what I am saying is that 3 to the power 3 is equal to 27. So these statements down the left here are exactly the same as these statements down the right. So we can write this down as a general statement. If we have a number x, and we can write x as a number a raised to the power n, then the equivalent statement in logarithms is to say that the log to the base a of x is equal to n. And these two are equivalent statements. Let's just develop a little bit of that. Supposing x were equal to 10, then we can write 10 as 10 to the power 1. So if I now take the log to base 10 of 10, then because 10 can be written as 10 to the power 1, then its logarithm to the base 10 must be 1. Similarly, if I had x was equal to 2, then 2 is just 2 to the power 1. And so if I take the log to base 2 of 2, again, that's just 1. So let's make that general. If x were equal to a, then we know that we can write that as a to the power 1. And so that the log to base a of a is therefore 1. And this gives us a general rule that works for any of our base numbers a.